Now, if you plug that data into SPSS, you're going to get on your output a table that looks like this. So it's going to have chi-square test at the top, and then you're going to see this information. Now, where we want to look first is where it says Pearson chi-square. That's the full name of this test, Pearson chi-square. Here's the actual value of the chi-square, 3 degrees of freedom, and is it significant? Yes, because this number is less than 0.05. So that tells you that this number here is significant. So that means we are going to reject HO, and we are going to conclude that our two variables are in fact related. Now you're going to have to go on and explain, well, how are they related, right? You just can't say they're related and then say, okay, see ya. People are going to be like, hey, wait a second, what does that mean to say that they're related? So here's where you have to go and explain using another table, okay? Now, before we get to that other table, I want to point out, the results, how you would write it in APA format, and it follows the same rules as the goodness of fit test. All right, so degrees of freedom, sample size, the actual value of chi-square, and then the sig value. We've already said it's significant because the sig value is less than 0.05, which means that party affiliation does in fact depend on age. It would be weird, by the way, to say age depends on your political party affiliation. So if I want to be younger, I can just vote Democrat. See, it kind of doesn't make any sense, right? Your age doesn't depend on which party you vote for, but which party you vote for does depend on your age. Makes more sense to say it that way. Looking over here, we can see that no cells have an expected frequency less than 5. So we've satisfied one of the assumptions. In fact, it says that the expected count, the minimum in our data, is 45. So we have nothing to worry about as far as that assumption is concerned. And then the next step would be to actually describe the relationship. All right. And so hopefully you remember that when we describe the relationship, it's almost like we're explaining an interaction effect in a two-way ANOVA. All right. But we have to ask SPSS to give us the percentages in each cell. Because normally when we do chi-square test of independence, we just get this. In other words, it shows us our observed data. There were 25 people who were Republican in the youngest age category. And then there were 75 people who were Democrat in the youngest age category. All right. So these numbers here, 25, 75, 35, 65, 50, 50, and 70, 30, those are our observed frequencies. But we want them converted into percentages. Because what if, most of your sample size was made up of Republicans or Democrats? Then it really wouldn't be a good idea to look at just the observed frequencies. All right. You want to convert them to percentages. Okay. So as a rule of thumb, always ask SPSS for the percentages in each cell. Don't interpret your results by looking at the observed frequencies. Now, to interpret this, you either go across. That means you're going to look at, in this case, the percentages within age. All right. Now, remember the trick from the lab? To know that you're comparing the right frequencies, they should add up to 100%. So if we want to look at percent within age, what we're doing in essence is saying, okay, if we just look at this youngest age group, so percent within this youngest age group, what were the percent of Republicans to Democrats? So within the youngest age group, 25% identified as Republican and 75% as Democrat. If we go down to this next age category, again, we look at percent within age. We're saying within the 30 to 49-year-old group within age, what percentage were Republican and Democrat? And it's 35-65. Okay, they add up to 100. Next would be 50-50, and then next 70-30. So we're looking at all these yellowy cells here. So we would then come to a conclusion and say, well, you know what? If we look at percent within age, we're asking for each age group separately. What percent were American, Republican or Democrat? What percent? How were they distributed within each age group? And they're not all distributed the same way, right? And what we can conclude is that the youngest people had a tendency to vote Democrat. Okay, same thing here within this younger age group. Most voted Democrat. But it began to change as they get older. Here it's 50-50. And by the time they're in this oldest category, it's flip-flopped. And now the majority vote Republican. Okay? So that would be how you'd explain it to somebody. But you can also look the other way and say, okay, well, let's look percent within party. So if you look at that, then what you're doing is you're saying for each political party separately, just all by itself. So we're going to isolate all the Republicans here. And we're going to say of the Republicans, what percentage were younger, a little bit older, and oldest. Okay, so you're looking at just the Republicans and saying, how was age distributed? So now you need to look at this green cell, this one, and this one. And those four numbers should add up to 100%. Okay, so of the Republicans, we can see if we look at these numbers, the majority, 38.9% of them, were older, right? This last age group was the one that occurred the most frequently among Republicans. But now we have to look at the Democrats, and we're going to look at the distribution of age for the Democrats. And if we look, it's just the opposite conclusion. The majority were younger. Okay? So in this particular case, whether we looked at percent within age or percent within party, we got to basically the same conclusion. Younger people vote Democrat, older people tend to vote Republican. That's all we have time for. This last slide just gives the conclusions that I went over with you just a second ago.